So the question that I chose to answer was problem 67 of chapter 19. I'm not going to read the entire question, so I'm just going to let you guys see it, and you can pause it if you want to read it real quick. So I'm just going to go ahead and get into how to solve the problem. But first I'm going to show you a good diagram, quick diagram of what the circuit is going to look like. Okay, so the first question is in the circuit to figure out how many electrons per second flow through the thin filament bulb. So the thin filament bulb is the long bulb, and that's what I designated it as when I was doing my work. And here it is for part A. What I first did was I found the resistance for the long bulb separately and did the same for the round bulb. Round bulb is thick filament and the long bulb is the thin filament. And in order to do that, I applied voltage is equal to the current times the resistance, and I manipulated that equation to solve for resistance is equal to voltage over the current. We know that there are two batteries, so the voltage would be 2, and we are given the current for each type of filament. So for the long one, I got 1.3 times 10 to the negative 18 ohms, and for the thick filament, or the round bulb, I got 6.7 times 10 to the negative 19 ohms. Okay? And now, using those resistances that I found, I have to figure out the equivalent resistance. We know that the round bulbs are in parallel, so you'd apply this, I'm going to focus on it, this portion. So you'd do 1 over R1 plus 1 over R2 is equal to 1 over R equivalent. And then for series, I just add the whole number to the answer that I get from the parallel. And I got that the equivalent resistance is equal to 1.64 times 10 to the negative 18 ohms. Now, using that value, I can find the current in the thin filament, or the long bulb, sorry. In order to figure that out, I just did current is equal to voltage over resistance, and again, voltage is 2, over the equivalent resistance we just found, and doing that, I got 1.22 times 10 to the 18th electrons per second through the thin filament. And that's how you do part A. For part B, it's asking for what approximations or simplifying assumptions did I make. I assumed, or I approximated, that the battery always maintained the same potential difference across itself. The potential differences along the connecting wires are negligible, and the temperature changes doesn't have a significant effect on the electrons per second that are flowing through the thin filament bulb. Now part C is asking for the surface charge. This is pretty simple. This is how you do it. So negative potential. So negative flows out of the negative side through this, and this is where it splits. So there's obviously less on this than there would be over here. And then now we're going to the positive potential towards the positive battery. And that's the surface charge.